Okay, so now let's determine whether two functions are inverses or not. So this is very closely related to one-to-one. All right, so it says, let f be a one-to-one function with its domain and range if g is a function with domain r and range d, which note these are opposites, domain d, domain r, and range r, range d. All right, so if f is a function with its domain and range, and g is a function with the opposite domain and range, then g is the inverse of f precisely when both of the following conditions hold, right? So if we take g of f and get exactly out what we put in, we get our x. And if we do like f of g of y and get exactly out what we put in, our y, that means we have inverse functions. So this is how we determine whether or not a function is an inverse or not. Okay, so notation, the way we talk about f inverse is typically written as f raised to the negative 1 for inverse. It's important to note that f inverse does not mean the same thing as 1 over f. This is a reciprocal, which is different than an inverse. Okay, so let's determine whether or not two functions are inverses with number 3. So let f be x squared plus 4. We're given a restricted domain here, greater than 0, x greater than 0. And then g is the square root of x minus 4, where x must be greater than or equal to 4. And we want to use this theorem above to determine whether f and g are inverses. Right? So that means we need to put f inside of g and also g inside of f and make sure that we get out exactly what we put in. So first, let's find g of f of x. So remember, composition of functions. Remember, f is on the inside, so we use that first. So we're plugging in our function f, which is x squared plus 4. And then we're replacing x in g with x squared plus 4. And then simplify. Perfect. We put x into our two functions and we got x right back out. All right, so we know that we have inverses if the opposite is true as well. So let's put g on the inside this time. So f of g of x. So our g is the square root of x minus 4. All right, so we're plugging this in, square root of x minus 4 for x in our f function. Well, the square root squared is just what's on the inside. And we can simplify. Awesome, we got out exactly what we put in for both of these, so that means f and g are inverses. So this implies f and g are inverses, or inverse functions. Okay. Part B of this question just says to sketch the graphs of f and g. I'm going to zoom out so we can see it all. Okay, so remember, knowing what functions look like will make this graphing portion very easy. All right, we know what a parabola looks like, centered in the middle, shifted up 4. So we know it's going to start up here, but remember, the domain is x greater than or equal to 0, so we only want the right side of this parabola. So it's going to look something like this. That's our f. Okay, we also know what a square root function looks like. This one it's on the inside, right? So it's going to be shifted to the right 4 units. So instead of starting here, 1, 2, 3, 4, it's going to look like the square root here. So this is our G. All right, so one thing, so we're going to do a little extra here. One thing that we can notice about inverse functions is that they are symmetric about the line y equals x. So if I drew a line y equals x, f and g should be like mirror images. Also, let's talk about the domain of inverse functions and the range of inverse functions. So we've already determined these two are inverses. So let's first look at the domain of f. All right, so it's from 0, so x is 0, to infinity, including 0. And the range of this function, so we're looking at possible y values, so from y equals 4 on up, so we're going to include 4 to infinity. And so this is the range of f. I missed that. Okay, now let's do g. So let's first find the domain of g. So this is the inverse of f. Okay, so the x values, x from 4 to infinity. And the range of g, so all of the y values, so this is going from y equals 0 on up to infinity. Now these should look similar, right? What do we notice here? The domain of f is the exact same as the range of g, and the range of f is the exact same as the domain of g. Right, so they're opposites. The domain of one function is the range of its inverse, and the range of the function is the domain of its inverse. So that's something to remember.